Okay. A quick review of what we have done in the last class. Last class we talked about the percentage of error. Percentage of error is the difference between the reading and the true value, of course, with respect to the reference value expressed as a percentage. This is different from accuracy in the way the percentage of accuracy is attached to the reading and the percentage of accuracy is attached to the instrument. Okay? We discussed about these differences. Then associated term is tolerance. Tolerance is designed by the designers, which is the amount of deviation that they tolerate during the manufacturing process. It is assigned value, whereas accuracy is calculated value. Okay, so tolerance is different from accuracy. We also differentiated this from accuracy. Range is from lower calibration value to higher calibration value, and span is the algebraic difference between the lower calibration value and the higher calibration. What is meant by algebraic difference? If the instrument is capable of reading from minus 40 degrees Celsius to 300 degrees Celsius, the range is minus 40 degrees Celsius to 300 degrees Celsius, whereas the span is 300 minus 40, so it is 340 degrees Celsius is the span of the instrument. Okay? So there is a difference between range and span that you have to be clear. Then we talked about calibration. It's a process of linking or establishing a relationship between input and output signals or output variables. It can be done statically or dynamically. Static calibration means we keep every environmental conditions in a very controlled manner. We perform calibration to static calibration. Dynamic calibration, we allow the parameters to vary its own. We don't purposely change, but we allow things to vary and then compute the calibration or perform the calibration. That calibration is called dynamic calibration. Now, this is threshold. Threshold is a new term for the few more terms that we have to continue today. We try to complete today. If not possible, next class all characteristics as per our lesson plan is over. Okay. So Moodle is ready. All lesson plan, model, question paper models, syllabus, everything I have uploaded, including the PPT. You can go through it. Okay. Italy, threshold means is the minimum input signal that is required. That is required to make a change from zero. Okay, an instrument initially reads 0. Most of the instruments start reading from 0. Of course, there are instruments start reading from minus value and then it comes. Okay. So threshold is the value that is a minimum value that is required to start reading from its 0 value. What is the small amount of signal that you have to give? For instance, if you have yesterday some people have used a board and tube pressure gauge as part of pressure measurement. As you apply pressure with the pedal and the pressure is getting built in the cylinder and there is a board and tube pressure gauge that measures the pressure. Initially the pointer was in the 0 and to move and show its first graduation, first reading, what is the amount of pressure that we have to give is called the threshold. Okay? Anything less than that threshold you give, maybe the instrument will be able to sense it, but we will not be able to make any meaningful measurement out of it. Okay. So threshold is the minimum value that we need to present it to the instrument so that instrument can produce reading which is understandable by us. Alright. Dead zone. That zone is called dead zone. Okay. You take an instrument, let's say same pressure gauge or even voltmeter, ammeter, anything, any meter that you can take. Let's take a voltmeter for example. Okay. And the voltmeter is capable of measuring from 0 volt to 20 volts, for example. You give 0.01 millivolt to the voltmeter. 0.01 millivolt to the voltmeter. Is it a 0 volt or some volt? Some voltage signal we are giving. But only thing, the quantity is very small. The voltage is very small. But we are giving the parameter called voltage. I mean, voltage is being measured. But if you see, if you take an analog meter and see, the needle will be almost in the zero only. You give 0.2 millivolt, 0.3 millivolt, 0.5 millivolt, you keep increasing it, the needle doesn't move at all from its existing position. Then beyond certain threshold limit, it starts moving. It starts moving. Then you keep increasing it, then it moves, goes to the first graduation and then shows the reading. You understand? Threshold is what is the minimum quantity that you have to give to show the first reading. First reading means first graduation in the analog scale, isn't it? Whereas dead zone is you keep on giving input, the needle is resting in the zero, not started moving. After certain amount of input only, it starts moving. Before it starts moving, what is the maximum amount of parameter that you have given for it to start moving? That value, that zone is called dead zone. Okay? The graph is here. Here it is input, here it is output. Here there is no dead zone at all. The moment 0.1 input is given, any parameter, temperature, pressure, length, velocity, whatever the physical parameter you are measuring. The moment I increase that value, the instrument produces the corresponding output. That means there is no dead zone. The ideal condition. Here, you have the output, you have input. I keep increasing the input up to certain limit. The needle doesn't move at all. The needle in the gauge doesn't move at all. And after that, it starts producing reading. And maybe my first graduation in the gauge will be somewhere here. So this will be my threshold. Whereas the point will be here. That will be, in fact, that zone from 0 to B is dead zone. Why? Even if I give input, the instrument does not respond. So that zone for which instrument behaves like a dead instrument, that zone is called dead zone. It may be on the positive side, or it can be both on positive and negative side, depending upon the type of instrument and the type of measurement that we make. Okay? So that entire zone, we call it as dead zone. Okay? Normally, if it is closer to 0, in and around 0, like from 0 this value, from 0 this value, it is called dead zone. You should not have dead zone in the middle. Okay? Up to 10 volts it will measure, from 10 to 11 volt it will have dead zone. I mean, like, from there you keep increasing the input, there won't be output. No, that kind of instrument you should not buy and use. Only around 0 you should use. You understand, no? Rahman? So this dead zone is normally around the 0 value. Okay? So dead zone is the zone in which there is no output even though the input is presented to the instrument. Is that clear? Resolution. Here I am going to present you some confusion with threshold. So resolution is the minimum input parameter that is required to make a tangible difference in the output reading. Resolution is the smallest input parameter that is required to make a tangible difference in the output. If it is a digital instrument, to produce next digit, what is the input signal that is required? For example, if it is a digital instrument, I am measuring 7.35 mm. A digital instrument, okay, gives. And this digit at all you cannot measure further, only 2 digits you can measure. Resolution is what is the amount of signal that is required to make next available reading. Next available reading is 7.35, next reading is 7.36 mm. This is the next available reading. To make this, what is the amount of input signal I have to give is the resolution. 0.01 mm is the resolution of that instrument. For digital instruments. For analog instrument also, to show the next reading, whatever is the amount of signal that is required is resolution. Is that clear? Okay. What is the difference between resolution and threshold? Threshold also we said something like that, isn't it? So what is the difference between threshold and resolution?
Threshold starts from 0.
Very good. Threshold is from 0, whereas resolution is from a non-zero point. Okay?
Sir,
Yeah.
so what will be the difference between threshold and base?
Yes. There is something called the inertia, because most of the equipments, most of the gauges were not are were W-E-R-E were mechanical, electromechanical devices. See something like this, looking like this. Here there will be, if you view voltage signal, there will be some magnetic reaction. Because of that, the needle moves, the magnetic flux is developed, and like a motor principle, electric motor principle that moves. Okay, not like the digital meters that we have today. And earlier, all these are all D'Arsenal principle. Okay, based on D'Arsenal principle, they work either like this or mechanical gauges. Mechanically, there are links, gears. There will be a pinion, that means it's a small gear in which the pointer is attached. And here there will be another gear. This will be rotated by a sector which is hinged. When you rotate like this, it will rotate, so it will rotate in a particular direction. So all this, either mechanical or electromechanical kind of devices, initially will have something called inertia. They are all compressed. You ask them to move, they say, excuse me. One man just move, no. Little more. Get out, man. You just give some push, little more extra bit, then they start moving. So they need little extra input for it to start moving. So normally, threshold will, for this instrument, this is resolution, and for the same instrument, the threshold will be maybe 0.2 or whatever, anything greater than this value. Okay, so if you give 0.01, it will not move. Okay, so you may have to give little extra to start moving because of the inertia of the system. In the digital instruments, it is your resolution will be less than or equal to your threshold. In digital instruments, in today's instrument, where there is no inertia, there is nothing, sir, what you give present input, it is showing output. Pakka, there is no instrument, ideal instrument. This and this will be equal. Threshold and resolution will be equal. Sir, no sir, it's some electromechanical devices involved or pure mechanical device, so inertia is involved there. So you will always find threshold is more and resolution is less. Resolution is less. Alright, any questions?
So, resolution is less than or equal to threshold in electromechanical or
Resolution is small. Threshold is big because whatever is starting from 0 is bigger quantity. Suppose you forget this idea, okay? You remember car. Car, initially we need more torque. That's why we put the first gear and then start the torque. Why? Huge mass resting there. You wanted the car to move. So you need to give big force. Big force means big torque. Force into radius is torque, so big torque. Put it in first gear. As it starts moving, you need only smaller torque. So second gear, third gear, and increase the speed and take advantage of the gear ratios. Okay. Threshold starting from 0. The instrument is idle. It's a mechanical, electromechanical device. Initially it is in 0. You wanted that to start moving. So you need more quantity. More physical quantity will give more voltage. More voltage will rotate with more force in case of D'Arsenal devices, D'Arsenal meters. D'Arsenal is a person who discovered this principle, so it is called D'Arsenal principle. Okay? And this is a mechanical device. Suppose if you pull this, the sector will move. These are all gears actually. This is a sector, this is a gear, this is a pinion. What is the difference between gear and pinion? If it is small, you call it as pinion. If it is big, you call it as gear. What is the difference between shaft and stud? If it is small, you call it as a stud. If it is big, you call it as shaft. Technical term, that's all. Okay. So if you rotate like this, it will go like this. So this gear will rotate like this. When this gear is rotating, this gear will rotate. So when this is moving like this will move like this will rotate in this direction, this will rotate in this direction. So depending upon movement. So bigger the movement, bigger the needle movement. Okay. So higher the parameter, bigger the movement. Okay. So threshold is supposed to be from 0, so you need bigger focus. Resolution is from a non-zero position, so even small quantity is good enough. Pedaling, you start the cycle from idle condition. Your first few rotations of pedaling will be tough because the vehicle is starting from 0. Whereas you already picked up some momentum, some speed, after which your pedaling is, the effort required is less because you are already in a momentum. You just have to supply the extra momentum to keep going. Okay, so that way your resolution will be normally small and compared to the threshold, or both of them will be equal in a better case. Any questions? Any other questions? Clear? Right. Next big term is precision. It's a big term. A lot of terminology is associated with precision. Accuracy is a big term that you should be very familiar. Precision is another big term. Precision is the ability of the instrument to reproduce same reading again and again for the constant input. I will not keep giving warnings. Yeah, you should sleep properly and come to the class and actively participate in the discussion. I will not keep repeating this. Okay? So pay attention, take notes, start writing, copy down so that you will not sleep. Since it is getting recorded, I will not keep disturbing the lecture and then pointing to you. Next time I send you out, that is a permanently you are out. And no one can get you inside my class. Right? That's a final warning for you. Precision is the ability of the instrument to reproduce the same reading again and again for the constant input signal that is given. What does that mean? I take a pressure gauge, give 5 Pascal or 5 PSI. PSI means what? Pounds per square inch. That's a unit of pressure. So 5 PSI and the reading shows something. Second time I take reading. Okay, 4.9 PSI the instrument shows. I disconnect it. Again I connect. I pedal and then give 5 bar pressure exactly. 5 PSI pressure exactly. Again I read. Maybe this time 5 PSI exactly it may read. Next time 5.1. Next time 4.8. Next time 5.2. There will be slight variation from one reading to other reading, isn't it? So, what is the ability of this instrument to reproduce the same reading again and again? If the instrument reproduces same reading, for example, let it be 4.9 PSI. First time I take 4.9 PSI. Second time I take measurement, input is same. Input is exactly 5 PSI. We assume so. Okay? Input is exactly 5 PSI. Don't ask me, sir, how exactly 5 PSI you will give. We have some mechanism by which we give, and I am measuring with the instrument 5 PSI. 4.9 PSI. Second time I measure 4.9. 10 times I measure all 10 times 4.9 PSI. Oh my God. That instrument, we say, it has the beautiful precision on earth. Whether is it the correct reading? What is the correct reading? 5 PSI is the correct reading. It is not producing the correct, no guarantee that it will produce correct reading. That is not described by the term precision. Precision does not guarantee accuracy. Precision tells the ability of the instrument to reproduce its own reading again and again for the constant input signal. Okay. So even if it produces wrong signal, even if it reproduces wrong reading again and again, we say the precision of the instrument is good. Precision of the instrument is good. Okay. So the qualitative definition of precision is the ability of the instrument to reproduce its reading over and over again when the constant input is presented. This is qualitative definition. Okay. And like accuracy actually means inaccuracy, isn't it? Accuracy actually means inaccuracy. By the term precision, we also mean imprecision. By the term precision, we mean imprecision. What do we mean? Imprecision. Why? The quantitative definition of the precision, it goes like this. Precision is plus or minus measured value minus average value divided by average value. Here there is a max. You should not forget that, into 100. So the difference between average value and measured value, take the maximum difference, divide by average value into 100 is precision. You get some number, plus or minus 2%, plus or minus 2.3%, whatever it is, some number you get. That number tells how imprecise that instrument is. How imprecise that instrument is. If you are very good at statistics, precision is something like standard deviation. Precision is something like standard deviation. Okay. Why, Sai? Why it is related to standard deviation? If standard deviation is small, that means the readings are not very spread across. They are lying closer to each other. If standard deviation is high, that means the variation in the data with respect to each other is far away. There are bigger differences, isn't it? So it's something like standard deviation in statistics. So if the smaller the number, the instrument will be able to produce its reading again and again close enough to each other. Close enough to each other. If the precision value is bigger, that means they will be scattered. The reading will be scattered. 5 psi I give as input. Sometimes I will get 4.3. Sometimes I will get 5.9. Sometimes I get 4. Sometimes I get 5 itself. Scattered here and there. A huge variation among the reading produced. If such things are there, the precision value, the numerical value that we get here will be bigger. Close enough. Close enough. Okay. Close enough to same number. 5, 5, 5, 5, 5, 4.9, 5.1, 5, 5, 5. All 10 readings are like that. Very close to each other. Precision. Here you get smaller number. So precision is actually meaning imprecision. Yeah, I am coming. There are 4 phases of precision. We are going to talk about that in a couple of minutes. Repeatability, reproducibility, stability, and consistency. All this represents precision. So what is the minor difference among those terminology is the subject matter of discussion for today. So we'll come to that. We will finish this in all respect and okay? Hold on for a few minutes. So plus or minus sign has the same significance as I explained for the accuracy. Percentage sign you have to put plus or minus 2% you have to put. Okay? If you don't put that percentage, again it is wrong. I explained what the reason when we discussed accuracy. And here there is a max. Normally students ignore this. In the examination again they make mistake. When they compute precision for each reading and then simply say there are 6 different precisions. No. One instrument can have only one precision. It cannot have 10 different reading and 10 different precisions. So you need multiple readings. Take the average of that. Keep that average. Each reading you subtract from the average. Take the biggest difference. Divided by the average into 100 plus or minus percentage will give you precision. You want me to work out some numerical problem on that, or you will be able to do it by yourself? If you want, I'll take an example and work it out on the board. Anybody needs a numerical illustration? In the examination, there may be numerical problems. I'm just applying this formula. All data will be given, you have to just apply and then calculate. you want, I'll work out a problem. If you don't want, I'll leave it. If it is manageable by you, I don't have to waste time on what you know on it. Anybody wants? No. Great, good. So you should not say sir has not worked out any numericals in the class, but question paper is full of numericals. So that's the point. So you should be able to manage this. Okay? Fine. Here comes the formula, and partially I have given this answer during the discussion here. Does more accuracy means more? Does more precision means more accuracy? I say the precision of the instrument is plus or minus 1%. Plus or minus 1%. Does it mean it will have so much of accuracy? Is there any guarantee? Yes or no? Harshvardhan, what do you feel? Why?
Accuracy is the final answer. The instrument has any error, it doesn't represent the correct value. Yeah, basically the reading is the same, similar numbers. It need not be equal to the final recorded value.
Can you briefly say what is the difference?
Like accuracy, my output should be 5. The instruments need not show 5, can show 4 real numbers. Precision is like it shows 44, 4.2, 4.1. Here,
My question is, does more precision means more accuracy? Huh?
need not
Need not be. Why? Actually, that is a skill to answer it confidently, but other person will not understand whether you know the answer or not know the answer. It's a beautiful quality for a politician and a captain of some games and things like that. In a public media, you have to give a answer. Very sensitive question is asked. You are not supposed to give the answer, but you should speak for 2-3 minutes about that subject. But the other person should not understand what we speak. Very good quality. Tomorrow you become a president of India or chief minister of Tamil Nadu or prime minister of India. So I don't want to have a war with you. You remember me when you go there. Okay.
since procedure means good repeatability, you might be getting the wrong answer again and again.
Beautiful. Yeah, that's precise. That's a scientist way of telling. No, you just tell fine. Yeah, black and white. Good. So repeatably. Precision means we have some reading, we keep repeating the same reading, it is precision. Whether it is right or wrong, no guarantee. Maybe wrong reading getting repeated many times, still it is wrong. Accuracy means it has to be close to the right answer. It has to be close to the right answer. Of course, there also you have to repeat same closer value again and again, then only it becomes accuracy, isn't it? So, more accuracy, does it mean more precision?
Yes.
Yes or no?
Yes.
More accuracy, does it guarantee a more precision?
Yes, sir.
Yes?
Yes, sir.
Alan says no. Alan, we would like to hear from you.
Sometimes, like the answer is 5, sir, and it's more accurate. May show like 4.9.
5.1, like that. That's a small variation. That means it is good accuracy. And precision, is it a wrong precision? Big precision?
May change.
Small variation. Good accuracy guarantees good precision. Whereas good precision does not guarantee good accuracy. Okay? So that's what is an illustration of this. See, this is the target. That is, let's say, value of 5 psi. Anything away from this is positive. Anything away from that is negative. Something like that you can keep. So here you have reading. Okay, let's say 4.5. Instead of 5 psi, 4.5 psi is away from G actually. But all the readings are closer to 4.5. 4.5, 4.44, 4.56, something. closer to 4.5. That means it has very high precision, but accuracy is less. Why accuracy is less? Because it is far away from the true value. Thus, one reading is here, one reading is there, one reading is here, one reading is here. Is it repeating the same value again and again? No. Whether the readings are closer to the true value? No. Neither it is close, neither it is close to the true value, nor it is close among themselves. So this case, the accuracy is also less, the precision is also less. Alright? Here we have very accurate instrument. That's what I asked. It's a very accurate instrument because all the readings are closer to the bullseye, the target. See, if all the readings are close enough, because it is close to the true value, it has very good accuracy. Because all the readings are closer to itself, among themselves, then it has good precision. So this has good precision, good accuracy. Is it possible to have more accuracy but less precision? Is it possible to have, imagine an instrument will have more accuracy but less precision? It's not possible. Because more accuracy means more precision. Okay. When I say more and accuracy, it is actually inaccuracy. What I mean is inaccuracy. What I mean here is imprecision. Okay, that you should always keep in mind. So this is an illustration of when one is high, what happens to that. Right. Till what time this class?
40.
40. Yeah? 40. So we have 4 more terms, which are different phases of precision. Different phases of precision. The 4 terms that I am going to discuss, all 4 of them means precision only. I may use the term precision or repeatability. Precision is very general term. It has 4 sub-branches. Repeatability, reproducibility, consistency, stability. So these 4, all of them representing one term, precision. Precision is the mother term. Okay, these 4 are children. So what is meant by repeatability? All 4 terms describe the ability of the instrument to reproduce same reading again and again. That is true. There are some more extra conditions attached to it. What is that extra condition? So repeatability describes closeness of the output readings when the same input is applied over the short period of time. Over the short period of time, I take measurement, and the ability of the instrument to reproduce the same reading again and again when the measurement conditions, instrument, observer, location, all other conditions are maintained throughout. I take measurement in a half an hour time or 1 hour time, short period of time. Same observer, I am performing the experiment, taking the reading. Same instrument, same lighting, same temperature, same humidity. No environmental condition changes. Observer doesn't change. Instrument doesn't change. Take reading. Compute the precision in a short period of time. Then I call this term as repeatability. Okay? Sir, can I call this as a precision? Yes, that's a general term. It is like Chennai. Chennai means what? Chennai, you say you take me to Chennai, where will you take me? You have to take me either to Paris Corner, either to Coimbatore bus stand, or you will take me to airport, or you will take me to Tambaram, somewhere, someplace. So Chennai is like precision. Individual places, okay, in Chennai, like repeatability, reproducibility, stability and consistency. Okay, so precision is a general term. Repeatability is a sub-term which tells the ability of the instrument to reproduce same reading again and again for a short period of time when observer, measurement conditions, instrument, all other things maintain the same constant. It's clear? This is for short period of time. Reproducibility is also for short period of time. Is also for short period of time. But I don't keep anything constant. First 2 readings I may take, second 2 readings I may ask you to take. All measurement conditions are allowed to vary. When I took first 2 readings, it is morning 10 o'clock, so temperature, humidity will be some value. Second 2 readings when I took maybe 12 o'clock, the temperature and humidity would have changed in the environment. Lighting would have changed, flow of air may change. I am not closing all the windows, I open the window. Morning there was a heavy wind, now there is no wind. I am not changing anything. Allow all measurement conditions to vary. I don't purposely vary, but allow natural things, whatever is vary. And then compute the precision. I give a specific name to that term. It's called reproducibility. Okay? Why this is important? Because I do some measurement here. Okay, I calculate the precision. I go to Ooty and do the compute the precision there. It should be same. Here altitude is low, their altitude is high. Here humidity is high, their humidity is low. Here temperature is high, their temperature is low. All conditions will vary. So repeatability is only good in the very controlled condition. Reproducibility is for versatile. Like any place, the repeatability will be good. Then you call that as reproducible. You will be able to reproduce that precision anywhere. So that kind of maybe you take reading from first floor or 8th floor of this building, you should get the same reading. Because their pressure is slightly less, ground floor pressure is slightly more. Their gravitational force also, there is a small change as you go up. So no such variation should affect the accuracy of the reading. So such calculations, the terms specifically you call controlled condition, you call it as repeatability. Allow the measurement conditions to vary, you call it as reproducibility. Do you understand? Both these terms are for short period of time. Both these terms are for short period of time. You take reading in a short period of time. If our measurement conditions are varying, you call it as reproducibility. If measurement conditions does not vary, you call it as repeatability. Up to this is clear? Another 2 terms. Stability, consistency. Stability is again same thing, but a longer period of time. And same measurement conditions, you call it as stability. The key terms are this: longer period of time and the measurement conditions are same, you call that term as stability. Longer period of time, allow the measurement conditions to vary, you call that term as consistency. So there are 4 terms. You should be able to distinguish one from the other and then write it down. Any doubts so far? Rahman, you understand all 4 terms? Now tell me all 4 terms. Let me hear from you.
Repeatability is over a short period of time conditions very constant. So the
What is precision?
precision is the measurement of the same input signal over again and again.
Again and again?
For the same input signal.
For the same input signal, again and again,
Measuring.
we are measuring. What should be the output?
It's initial.
A reading should be same or more or less same. That is precision. What is repeatability?
Repeatability is this also precision, which is taken in over a short period of time and with the measurement conditions being constant.
Or constant. Reproducibility?
Over a short period of time and conditions are
Very good. Okay. What is the difference between consistency and stability?
Consistency to take measure value where for a long period of time and conditions are same.
Consistency.
Sorry, for consistency conditions are different, sir. And
For consistency, what is the
for a long period of time conditions are different.
huh?
Conditions
Conditions are
different.
different.
Consistency.
Consistency.
sorry, sir, consistency conditions are different, sir. For stability conditions are same.
For consistency, conditions are
Different.
for consistency. Consistency. Long period of time. Conditions are same. For consistency, conditions are same.
For longer period, different conditions are different.
Different. Is it different or same?
Different.
Sure. 100%. Because you should not manipulate answer based on my facial expression. Because I give expression for all answers. You should know clearly what it is for yourself. Okay. So when I say constant, no sir, very, no sir, constant. That should not be manipulating my expression. Okay. Listen carefully. Okay. Fine. Good. So 4 terms: stability, consistency, repeatability, and frequency. Drift. This is the last term. We'll stop here. Drift is the amount of difference among the readings at different time of measurement for the same input value. Meaning, we give some input value, the instrument will give slightly a more value or slightly a less value. That difference will be there throughout the measurement. That's called a drift. There is a shift. For example, you take a spring balance. With spring balance, the stiffness or the spring would have slightly expanded permanently once for all, maybe because of the misuse. So instead of 0, initially it will be 0.2 grams, 0.2 kilogram, already it is departed. Without any weight, it will show 0.2 kilograms. So you put 1 kilo, it will show 1.2 kilograms. You put 2 kilogram, 2.2 kilograms. So 0.2 will be the error always in the instrument. That's called drift. That's called drift. If this is computed when no input is given, when no input is given, what is the drift you compute? That is called zero drift. That's called zero drift. So any instrument before starting, you should look for zero drift. So that if it is there, if it is electronic instrument, zero drifts can be adjusted, the zero setting can be done. I think yesterday in the lab, some of the instruments you might have adjusted 0. That's because you are adjusting the zero drift and then making zero drift, nullifying the zero drift. Then your measurement is good. But if it is mechanical instrument, it is not all that easy all the time. So that may be manually you may have to correct. You compute the drift, keep it in memory. While taking reading, you subtract or add accordingly so that you get the measurement.
What is the calibration?
Sorry?
It's called as calibration.
Which is called calibration. Yeah, calibration actually has slightly a bigger meaning. This is also the error. For this also we can recalibrate. Drift is because of wear and tear or permanent elongation, permanent deformation. If it is electronic instrument, the capacitor value slightly changes because of overheating or some other problem, things like that. So that you can adjust it and reset it to a new value, it will work. Okay. So this normally we don't call it as a calibration. It's only a adjustment in the zero setting we call. So that before start using, you just set the zero setting. We can call it as a calibration at zero value because you give some input value, you are correcting that output value and establishing the correct relationship. Nothing wrong in calling it as a calibration. But generally we, in the commercial term, we call it as zero setting. You go to a company, you say, no, I am calibrating it now. They will laugh at you. What this fellow is talking. So theoretically it is right, but when you talk among the learned people, you should use the right term. So there you should say, I am doing zero setting. I'm setting it back. We stop here and then we continue.